Okay, so in this video we are moving on to factorizing polynomials to find zeros. And in other words, basically, we are just trying to solve polynomial equations. We're going to be looking at some higher powers, so powers of 3, things like these cubics and stuff like that. Now, we're going to be applying things like the factor theorem that we learned in the last video, but before we do all of that, we need to revise some stuff for solving some other polynomial equations that we've done in the past, these quadratic ones like the one I have here. Now, if we recall from quadratic equations that when we had things in this particular form, in this expanded form, it wasn't very useful in actually helping us to find the solutions. So, written like this, it was not exactly useful. You can't just look at this and find the values of x that satisfy this solution. Just that satisfy this equation, I should say. What we did instead was we factorized this using a series of tools, our PSF, our things like the quadratic formula just to find solutions, but the ultimate goal was to get this in a factorized form. So this would be something like x plus 1, x plus 3. I'm not going to go over how you factorize this because it is assumed knowledge for this section of the course. But once we got it in this form, we remembered that, well, when things are written with brackets, there is a multiplication happening here. So this is where we used the null factor law. We were saying, well, okay, two things are multiplying here, and the solution is 0. So the only way to get an answer of 0 when two things multiply is the case where either of them is 0 itself. So this entire thing, x plus 1 is 0, and this entire thing, x plus 3 is 0. That is the only way we can get this solution on the right-hand side. And from here, we just got these two little mini equations that we could solve pretty easily. They were usually 1 or 2 step equations, and boom, we were happy and we could move on. Now, when we're looking at particularly cubics, when we look at to the power of 3, like these ones that we were factorizing in the previous video, or working with remainder theorem or division of polynomials, these are going to have slightly more solutions if we were to use the null factor law. And in this video, we're going to build up to the very last question in which we factorize a cubic and then solve to find all of the zeros. But just so we can practice using the null factor law a little bit, I'm going to start us off with two questions which give us a cubic in fully factorized form. So I have x minus 1 times x plus 2 times x plus 5 equaling to 0. Now, the same principle still applies as the example I gave above. We're still multiplying each of these three. That's the sort of hidden operation here. Now, once again, the solution, well, the answer here, thing on the right-hand side, is equal to 0. So the only way that we can get 0 on the right-hand side is for either one of these guys here to be 0. Because remember, we're multiplying. So the only way you can get 0 as an answer, when you multiply two numbers, or three numbers in this case, 0 has to be one of them. So we can either get a case where x minus 1, this whole thing equals 0, where x plus 2 equals 0, or where x plus 5 equals to 0. These are our only three options. And just like with quadratics, we break this up into three mini equations and then we just solve the simple one-step equations. So here our x is going to be 1, in this case our x is going to be negative 2, and in this case our x is going to be negative 5. And if we substitute either of these solutions back in for x, I'm going to get 0 on the right-hand side. So this is a fairly straightforward example to start off with. Let's try a slightly trickier one before we go into doing this entire process in the next question. I have once again a fully factorized cubic polynomial, and I'm trying to find the zeros here. So the values of x that produce a 0 answer. Now, once again, we're talking about multiplication here. So the only way we can get a product of 0 is if either of these terms are 0. So, like before, I break this up into 3 separate equations. One of these is 2x minus 3 equals 0. One of these is x plus 7 equals 0. And one of these is 3x plus 1 equals 0. Okay, the only difference here is maybe there's a couple of extra steps, because as you can see, this one over here, this is a 2-step equation. So I add the 3 over first to both sides, gives me 2x equals 3, and then divide by 2 gives me x equals 3 on top of 2. This one's an easy 1-step equation. We just subtract 7 from both sides, and we get another 2-step one here, where we can subtract 1 first, and then divide by 3 to get negative 1 over 3. So just a little bit of a recap with null factor law, but just showing you guys that no matter how many factors we have here, we've got 3 because this is a factorized cubic polynomial, we can apply the null factor law as much as we want. Now, we're moving on to the next bit, which is a little bit trickier. This just gives you a regular polynomial, and we want to solve this equation. We want to find the zeros of this particular polynomial here. Minus 6 equals 0. Okay, so what's tricky here is we've got a polynomial here, p of x on the left-hand side, x cubed plus 2x squared minus 5x minus 6. But we don't really know what divisor in the form of x minus a is going to be a factor here. So with these types of questions, there's a little bit of trial and error that we kind of have to do. We just start off with one particular form of x minus a, for example, x minus 1, and we kind of just work our way up, and eventually we're going to find something that goes into it really nicely. But thankfully, because of what we learned from factor theorem in the last video, we don't have to just go and divide these, just doing these really long processes of polynomial long division until we get a remainder of 0. Our factor theorem tells us that if this is a factor, so if x minus a is a factor, then p of a will equal to 0. So that means that we can just trial a few of these values of a to put in here, and the thing that gives us 0, we immediately know based on factor theorem that that's going to be a factor. So let's just start off with one, for example, because like I said, we need to do a little bit of trial and error. Let's try x minus 1. In other words, our a value here is going to be 1. So I'm going to try here p of 1. I'm going to substitute this a in place of all the x's. So this will give me 1 cubed plus 2 times 1 squared minus 5 times 1 minus 6. Okay, and once we get that, you guys can pop it into your calculators, but we have 1 plus 2 minus 5 minus 6, and we can pretty easily see here this is 3 minus 11, and we can immediately say that this does not equal 0. So we can say that therefore x minus 1 is not a factor, because when you substitute this a in, you do not get 0. You get a non-zero number of negative 8. So now we kind of just have to keep going. So let's try another case. Let's try here x plus 1. Or in other words, a, I should say, equals minus 1. Let's check this. So we have p of negative 1 equals to negative 1 cubed plus 2 times negative 1 squared minus 5 times negative 1 minus 6. And I'm going to save you guys having to do all of it. This is eventually going to simplify out to give you 0, just because I'm conscious of time. You can check this in your calculator if you want, but therefore we can say x plus 1 is a factor. So now this is where we want to, in order to find these zeros here, we want to fully get this guy here factorized to look something like these examples up here, where we can apply the null factor law. Now, this is where it gets a little bit tedious and laborious, but we can say x plus 1 is a factor, so we can represent p of x as x plus 1 times q of x. Why am I not putting a remainder here? Because I know since it's a factor, I'm going to have a remainder of 0. So normally we would write this plus r. I've just not done that because by our factor theorem, I know that x plus 1 is going to give us a remainder of 0. Okay, so now that we have this, we can basically just divide through our polynomial. So our x cubed plus 2x squared minus 5x minus 6. And because I've gone through division of polynomials at length in a previous video, I'm just going to leave this for you to do as an exercise, because the main thing we're trying to get at here is factorizing and solving these types of equations. But when you divide your polynomial by this divisor of x plus 1, your quotient is going to be x squared plus x minus 6. Okay, so that means that we can write our polynomial p of x as x plus 1 x squared plus x minus 6. So that means that this guy up here that I highlighted in orange, we've just written this in a different way from what we learned in dividing polynomials a few videos ago. But as you can see, it's still not quite, this thing's better because it's broken it up into one factor, but this thing here, we still need to further factorize this. This just gives us a quadratic. So we know how to factorize these. If we just take our x squared plus x minus 6, using our PSF method that we did before, we want two numbers that multiply to give negative 6, add to give 1. So those are going to be 3 and 2. Okay, so this means that we can write p of x as x plus 1, and now we can factorize this. Because I have these factors, I can rewrite x squared plus x minus 6 as x plus 3, x minus 2. And that is what I'm going to write here. Plus 3, x minus 2. Now, we are trying to find the zeros of this, so we're trying to solve for my polynomial equaling to 0. I'm trying to find these zeros. So, I'm just going to copy paste this thing down here and set this to equal 0. And once again, now this looks really nice. This looks like what we used our null factor law for. We had 3 different factors all multiplying to give 0, so we can set up 3 separate equations to find the solutions of x to this equation that give 0 as an answer. So I've set this one up here. I can also say that x plus 3 here equals 0, and x minus 2 equals 0. And these are just the easy one-step equations like in our first example from this video. But this is how we can find these zeros of our polynomial equations, particularly these cubic equations, which are going to be really, really useful in our next video when we look at actually graphing some polynomials and sketching these types of graphs. This will become very useful for finding x-intercepts, if you remember from our work with quadratics, but the main takeaway here is the process for solving these. So we're looking at our unfactorized thing here and just doing some trial and error to find a factor of this polynomial, something that'll give the p of a to give 0. So we just try a few, see what works. We just keep going until we get something obeying the factor theorem, like we got here for p of -1. And once we know that that is a divisor, a factor of this, we can just do our polynomial long division, which I've skipped in this video because it would have been too time consuming, and we can get a quotient. Now, once again, the quotient is, with cubics especially, it's almost always going to be a quadratic, so we can factorize this quadratic out. And we get something with which we can easily apply the null factor law to. Same as quadratics. That brings us to the end of the video. Thank you so much for watching, and I'll see you next time.